Welcome back. Now all exam has announced. So I will tell you some beautiful thing. Today I will tell you how you will stay in positive always. Because this is the time of study. So I will tell you clean your study room because this is very important for keeping high energy. Are you keeping high energy in your room? Because that energy reflects yourself. The most important technique that you can apply your life when you will feel boring and stressed, then go your room and just clean and organize your room in beautiful way. Then you will feel and happy moment. So always try to clean surrounding you because surrounding you always will reflect inside you. And when you clean your study room in beautiful way, then you will feel some calm moment. Just try. Come back. In my earlier video, I had discussed about prime ideal and number of prime ideal, and I had seen quotient ring with prime ideal. And today at first I will say if F is a field, then F has exactly one prime ideal. And I hope my all viewers have understood why this is. Field always imply integral domain, and I had discussed in my previous video, in integral domain, ideal 0 is only prime ideal. Okay? Do all of us know if F is a field, then F has exactly two ideal, which I had discussed in my previous video. In field, there exist only two ideal, 0 and 1 whole field. And since I is a prime ideal, since prime ideal always be proper ideal, so this is cannot possible. Only possibility is 0 ideal. Means when F is field, there exists only one prime ideal. This is the 0 ideal, similar to integral domain. Are you getting? Well, now I will ask you one interesting example. Find all prime ideal in CX. Just think. This is very easy. Here, all prime ideal is look like the set such that x minus alpha, where alpha belongs to complex number. And this is because C is algebraically closed. Here, any polynomial of degree greater than 1, you can write it as product of distinct linear factor, and this linear factor does not belongs to ideal. So here only prime ideal in CX look like x minus alpha, where alpha belongs to C. I will discuss one different type of ideal, maximal ideal. The concept of maximal ideal be, let R be a commutative ring with unity, and let I be any proper ideal of the ring R. Then this ideal I is called maximal if I is a proper ideal, that means I not equal to whole ring R. Second, if J is an ideal such that I contain J and J contain R, then either I equal to J or J equal to R. This is actually means M is maximal element in the partially ordered set of all proper ideal of the ring R. For example, consider the ring as a integer We all of us know I equal to nz where n be non-negative integer be an ideal of this ring. And here the prime ideal when n is a prime number. Let's see which ideal are maximal. When n equal to 0, then 0 is not a maximal ideal because the ideal 0 contained in 2z and 2z is contained in z. That means there is an ideal 2z. This is strictly bigger than 0 and strictly smaller than z. So, ideal 0 is not a maximal ideal. And when n equal to 1, then this ideal equal to just whole integer. Obviously, this is not maximal. Now consider n equal to 2, then ideal would be 2z. Consider this ideal be not maximal ideal. That means 2z contain a proper ideal j which also contained in the ring z. Sorry, here 2z. And since 2z be the all even integer and since 2z contained in j, so obviously j contain an odd integer. Consider j contains an odd integer. Say this is a. That means a minus 1 belongs to 2z which by assumption contain in j. Therefore, I have got a contain j and a minus 1 also contain j. That means their subtraction, since this is the member of integer, so obviously their subtraction mean a minus 1 belongs to j, that imply 1 belongs to j. And we all of us know when an ideal contain 1, that means this ideal is equal to the whole ring. That means this is equal to integer. That means any ideal which contain 2z properly, this is actually the whole ring z. That means the ideal 2z is a maximal ideal. Similarly, we can tell 3z is also maximal ideal. And when n equal to 4, then I would be 4z. Then obviously 4z contain in 2z which is also contained in z. That means there exists an bigger ideal from 4z where 4z contain in this ideal, where this ideal not be whole ring z. So obviously the ideal 4z is not maximal ideal. Okay? Similarly, actually nz be maximal when the number n is prime number. Let's recall earlier video. In my earlier video I had told you in z when n is prime number and 0 ideal be prime ideal, but maximal ideal be only n be a prime number, not 0. There exists a nice proposition: if R be a ring, then every maximal ideal always be prime ideal. Every prime ideal does not always imply maximal, but every maximal ideal always be prime ideal? Just notice in integer, when n be a prime number, then this is all maximal ideal. So obviously this is the prime ideal. But also 0 be prime ideal in integer. But 0 not maximal ideal. So prime does not always imply maximal, but maximal always imply prime. For example, if we consider the ring Z24, then it has two ideal generated by 2 and ideal generated by 3, and both ideal also contain the subring ideal generated by 6 and 2 contain ideal generated by 4 and 6 contain ideal generated by 12. Also 4 contain ideal generated by 8 and both 8 and 12 contain in ideal generated by singleton set 0. Okay? And notice ideal generated by 2 and ideal generated by 3. There is no ideal between the entire ring Z24 and this ideal. So obviously this ideal are maximal ideal in Z24. Are you getting the idea? I hope my all viewers have understood clearly how we have to find maximal ideal in any ring. Okay? Now I will see one different type of maximal ideal. The maximal ideal of this ring Z3i cross R cross Z11i. I had seen in my earlier video the number of ideal of cross product or of any ring. Also I had seen number of prime ideal of this type of ring. We all of us know there exist 8 ideal, one set containing 0, I2b 0 cross 0 cross Z11i, I3b 0 cross R cross 0, I4b Z3i cross 0 cross 0, I5b Z3i cross R cross 0, I6b Z3i cross 0 cross Z11i, I7b 0 cross R cross Z11i, and I8 would be the whole ring, that means Z3i cross R cross Z11i. Now we have to find the maximal ideal. This ring not maximal ideal because this ring is contained in 7 ideal. So this ring is not a maximal ideal. And now notice the ideal I2. Notice I2 is contained in I7. That means I2 contained in I7, which is also contained in the whole ring. Here consider this ring is R. So similarly I2 not be maximal ideal. Now notice the I3, and similar to first we can tell easily I3 contain I7 and I7 also contain the ring R. So obviously I3 is not a maximal ideal. If we consider I4, notice I4 contain in the ring I6. That means I4 contain the ring I6, which is also contain the ring R. So this ideal also not be maximal ideal. That means only maximal ideal be I5, I6 and I7. Because since this is the whole ring, I8 also not be maximal ideal. And these three ideal not contain other ideal without the whole ring. I will see, okay, the general from R1 cross R2. What will be the maximal ideal of this ring? Consider M be maximal ideal of this ring R1 and consider I be any ideal, then obviously M cross I containing M cross R2 which also contain in R1 cross R2. Okay. Now I will see, is this ideal is maximal? Consider this ideal not be maximal ideal. Let capital M be maximal ideal. See the proof of R1. Then obviously M cross R1 be ideal of R1 cross R2. Let I1 cross I2 be any ideal of R1 cross R2 such that M cross R2 containing I1 cross R2 which also containing R1 cross R2. And from this line we can tell easily M contain I1 which contain also R1 and R2 contain in I2 which is also contained in R2. And since M is maximal, so from this line we can tell either M equal to I1 or M equal to R1. Okay. Therefore, from this line we can tell I1 cross I2 would be either M cross R2 or R1 cross R2. That means this expression I can tell easily M cross R2 actually be maximal ideal. If J is maximal ideal of R2, then R1 cross J is maximal ideal of R1 cross R2. That means the general form is the maximal ideal of R1 cross R2 is maximal ideal of R1 cross R2 and also R1 cross maximal ideal of R2. This is the general form of the maximal ideal of R1 cross R2. And few minutes ago I have got every maximal ideal always be prime ideal. So these two ideal also be prime ideal of R1 cross R2. Similarly, the maximal ideal of R1 cross R2 cross R3 would be maximal ideal of R1 cross R2 cross R3. Also, R1 cross maximal ideal of R2 cross R3 and R1 cross R2 cross maximal ideal of R3. That means this ideal has 3 maximal ideal, and since maximal ideal always be prime ideal, that means there exist also 3 prime ideal. Now let's come back this question which I had discussed few minutes ago. This is the cross product of 3 ring, and notice here all are filled. So both case there exists only one maximal ideal and this is only 0. So by previous rules we can tell Z3i cross R cross singleton set 0 is the maximal ideal of this ring. Here 0 is the maximal ideal of Z11i, and also Z3i cross 0 cross Z11i is the maximal ideal of given ring. Here 0 be the maximal ideal of the ring R, and 0 cross R cross Z11i be the maximal ideal of this ring. Here 0 be the maximal ideal of Z3i. So these three ideal be the maximal ideal of this ring. Are you getting the idea? Well, I hope my all viewers have understood about maximal ideal. But I will highly recommend you see this video with pay attention, because this topic is very important for any competitive exam. See you soon. Stay safe and stay positive always. And don't forget to do subscribe my channel and press like button. Thank you so much.